Alright, this is Dr. Carroll with a video about class templates. Well, you've probably seen lots of examples of typedef floating around as a way to make code reusable in different forms. Let's say you were looking at a stack class and you're looking through the code, you notice that you see that they have a typedef stack element, and we're going to refer to that as an int. Okay, and so you might see that way you can change from int to a char or something like that. Well, there's some disadvantages with doing this and having the typedef. Is one, you have to recompile it every time that you want to change that, reuse something different, and you might not have access to those files to be able to recompile it. Also, what happens if you need two different implementation, two different types there? You can't have two stacks. You can't have an int stack and a char stack with a typedef. Well, there's a better way, and the better way is, not surprisingly, to use class templates. Templates allow for intelligent code reuse. Let's look at an example. Let's say we have a class, we'll call it pair. It stores, not surprisingly, just a pair of variables, basically. It has two data members, two private data members here, and a very simple constructor, and we have set first and then set second and so on. Well, let's just simplify. And then in a main, we have just a mixed pair, and we're going to pass it a integer and a double. So now what if we wanted to template this class? What would we do? Well, there's a couple rules to templating that we need to follow. Let's see if I can get all this on the screen. One is that the functions defined outside the class must be templated. Okay, well, that goes back to the function templating, and we know how to do that. You type in template, and then we type name, and we can do, there's going to be two, so let's make sure we do two. Type name T1, T2, and we'll do T1 here, and hey, we're good. We can copy and paste this up here. We do need both of them here. T1 here and T2 there, and looks good. Okay, so there's rule number one. But also, we need to apply the template to the class as a whole. And here we said we wanted two types, so then we can take this int here and make it T1, and make this T2, and we can make this T1, and make this T2, and then probably should have done a search and replace all. Okay, and then we're good. Let's see. Oh no, we'll want to make that call, update that to be right. Except instead of putting the parameters here for the constructor, then what we do is we put them on the class itself. So let's see, so we're doing a double, and we define that the class is templated instead of that the constructor is templated. Now, the second rule says all uses of the name of the templated class as a type must include the parameterized data type. Okay, so that refers to here. Here, pair is a type, so we need to give it the template, the parameterized type. We need to say, we don't have a pair class anymore. We have a templated pair class. And similarly for our other method here, you can see why I dropped the other one. We're using pair as a type here because that's before the scope resolution operator. We use it as a pair. Notice we're not using it as a type here, so we do not put it there. Okay, we don't put it there. And now we have a parameterized class. And you can see this class is It's available, and you can play around with it in the private section for chapter 1. Okay. So let's review though an important point so that how to make this work. Header files are never compiled. They're pre-processed and are usually included in one or more CPP files, but they're never included. Okay. Well, that's important because a templated class is not a class, just as a templated class is a templated function is not a function. It's a template or a pattern for a function. A templated class is a template or pattern for a class. And so consequently, we need both the declaration and definition of that class available to the compiler to get the information to know what the parameterized type is. Okay? Consequently, we can't compile with a traditional CPP file. The compiler doesn't know everything it needs to know about the class just with the CPP file, the implementation file alone. It can't figure out, for example, the memory footprint it needs for a templated class without knowing what the templated variable will be. Well, there's a solution to that. And the solution is to put the implementation in the header file. I know you probably had instructors say never do this. Well, this is the exception. When it comes to templates, the easiest way to do it is put the implementation in the header file. Okay? Remember, the header file is not going to be compiled until it's included, at which point the template variable will be declared. For example, let's imagine you have a templated linked list class that has an implementation in the header file. And so then when we want to define an object of that linked list class, and we're going to pass it the templated parameter to that, then it can compile because we have the implementation, the declaration, and the template parameter all together. Okay? So when things don't work, make sure that your implementation is in the header file. Let's take another look at rule number 2. All uses of the name of the templated class as a type must include the parameterized data type. Well, now to reinforce that, let's add in a copy constructor here and a in the declaration and a assignment operator. So here, this is it's copy constructor, so we're using pair as the name of the class. But here, when we say for a copy constructor, we want to pass in a reference to a type. The type pair here is used as a type. Consequently, we have to put the templated arguments here because pair is a type. There is no longer a pair type. There's only a pair with templated arguments. Additionally, here pair is being returned, a reference to it for the overloaded assignment operator, and we're going to pass in a reference to a templated pair class. Okay, that's to reinforce number 2. Okay. Now that I brought that up, which is which here? So pair is the name of a class template. It's a pattern. It's not the name of a type. It's not the name of a type. When we use pair with templated arguments, but T1 or T1 and T2 or whatever we come up with, it's a parameterized name of a class template. But it only becomes a type when we specify what T1 and T2 are. So it is only when we specify what those template parameters are, only then do we have a type. Only then is it a class. Well, that's it for class templates.